the other hand, if this is a very infrequently used road, and that sequence number is 50, then we can conclude that this road is in fact stale, because the source purged from the destination far more recently than this node. So this road would then be discarded. Yes?
Is the sequence number keeps increasing, or it goes back to 0 sometime?
It has to go back to 0 sometime, obviously, because the field is finite. But I can't remember how long it is. I mean, it would have to be, the field would have to be long enough that probably millions or billions of packets would have to be transmitted before it pulls over.
If it starts from over again, the road is completely wrong.
That's right. So if the sequence number rolls over, then you have a big problem.
No, they should, all sensors should know that that's possible.
And if your numbers are in the billions, and you have one that's like 99 billion and one that's like 2,
It's like 2.
you have to assume that maybe the 99 billion one is actually like
So-
older and the 2 one is newer.
So I don't actually know how this problem is solved. This problem also occurs on the wired internet. Sequence numbers are used actually in much the same way. Actually, no, excuse me, not in much the same way. They're used in, I think they're used in TCP. There is some famous internet protocol, I think it's TCP, that uses sequence numbers. And this same kind of problem crops up, where the sequence numbers, if they roll over, you've got a big problem. So I didn't look up how that was solved, I'm not sure. But I mean, that's just a technical issue. There would have to be some well-defined solution to that, and I'm just not sure what it is. Okay, but good question though. Okay, so if the neighbor has no route, so if you're not lucky enough, so remember that whenever a node is not part of an active route, it throws out its routing table. It doesn't, after a certain amount of time, it discards all of its routing information, and that's because all of its routing information is very likely to be unreliable, so there's no point in keeping it. So what that means is if it's relatively unlikely that you'll just happen to be very close to a route. In the more likely event that the neighbor has no route to the destination, then what it will do, as you might imagine, is it will rebroadcast. It'll rebroadcast the route request. And it'll increment the hop count. So I should have said, remember, hop count was one of the fields in the route request. So clearly it starts off with 1 when it's broadcast to just the neighbors. Once those neighbors rebroadcast it to their neighbors, the hop count is incremented. That's how we keep track of the length of these paths. So obviously, sooner or later, assuming that the destination is connected, assuming that a path exists, it will be found. So if you start with yourself, and you go to your neighbors, their neighbors, their neighbors, and so on, it's inevitable that either you will intersect with the route, or you'll actually find the destination. So eventually, a route must be found if one exists. We won't deal with the case where the network is changing so quickly that while you're doing this process, routes appear and disappear, because that would cause severe problems. But if the network is changing on the order of tens of minutes to hours, this would definitely succeed in finding the route if it exists. Okay, so setting up the route, we go by the reverse path. So basically, when a device receives a route request and passes it along, all nodes remember the source of the route request that they received. So working backwards,
They actually need a route back to the guy that asked them for a route.
yeah. So that's why there's a unique ID. So you don't pass in circles. So in other words, the significance of the fact that the source address and the broadcast ID uniquely identify this packet is that if you see it again, you don't forward it again.
So the person that when they rebroadcast it, they put their own address as the source. Like they're looking for a path to the destination now.
Good question.
Because otherwise, how do they know?
Otherwise, how do they know?
They have to go back all that way, right? And they don't change the DSN.
No. Actually, no. That's not necessary. So I receive a route request. I remember who I got it from, and I rebroadcast it. So if everyone just remembers who they got it from, then eventually, I mean, each node in the sequence is smart enough to know that it's not the originating node.
Okay,
So-
so there is that information being kept
That's right.
when they get this information.
So once a route is found, once this growing ball intersects with the route, in other words, once I find my neighbor who's a member of that route, I remember, oh yeah, I received this request from so and so, so I'm going to pass back along that link that I found the route. And then that guy will be like, oh, I received the request from so and so, so I'm going to pass back and so on and so on and so on.
What was the question?
The question was, don't you have to, when you pass the route request, don't you have to replace the source address? In other words, if A passes a route request to B, when B forwards it, does B put its own address as the source? The answer is no, that's not needed. All that's needed is that if you have a circle, like this, and that route request comes back, that B realizes it's already seen it, which it does from the source address and the broadcast ID, and it doesn't re-forward it.
So how is the newfound node is keeping track of the old node destination? Like how, if we don't change the source address, how are we keeping track of the previous? For example, B.
Right. So it's because B remembers that it received the transmission from A. So in other words, this will all become clear in a second.
Yeah, because that's in its own packet.
Yeah. Okay. So all nodes remember the source of the route request. So therefore, when a route is found, working backwards, the route is discovered. So here's how. So I have A, B, C, D. So I want to set up a route from A to D. So A sends a route request to all its neighbors. B doesn't know where D is. This is a route request to find D. B doesn't know where D is, so it just forwards the route request again to all of its neighbors.